All right, problem 6. Let f of x equal sine of x squared plus cosine of x. The graph of y equals the absolute value of the fifth derivative of x is shown above. All right, write the first four non-zero terms of the Taylor series for sine x about x equals 0, and write the first four non-zero terms of the Taylor series for sine of x squared about x equals 0. All right, if you know your formulas, we do have a formula for sine of x. I'm going to, at least just to help you out here, I'm going to assume that we just don't know our formula for sine of x, so I'm going to actually just recreate it up here. I know that f is equal to sine x, so f prime will equal cosine x, and then f double prime will be negative sine x, and then f triple prime will equal, let's see here, negative cosine x, and I don't know how far I'm going to need to go. The fourth derivative will be sine x, and we'll just see how far I need to go. Okay, so the first four non-zero terms, the first one, remember, we're going to do f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial plus f quadruple 0 x to the fourth over 4 factorial, and I might need to keep going. So, all right, so then anyway, f of 0, the sine of 0 is just 0, so that one is gone. F prime of 0, the derivative of cosine 0 is 1, so this is going to be x. And then f double prime, the f double prime is a sine, so now the sine of 0 is gone once again. The triple derivative at 0, that will be negative cosine of 0, so that will be negative 1, so it will be negative x cubed over 3 factorial. The fourth derivative, if it's going to another sine, so that's going to cancel out, so I guess I get to keep going here. So let's do the fifth derivative. I'm guessing I'm going to have to get to 4 terms. I'm going to have to go 4 times here. I mean, another few. X to the fifth over 5 factorial plus f6, 0 x to the 6 over 6 factorial. I think I'm going to have to go one more. Okay, so then the fifth derivative will be cosine of x. The sixth derivative will be negative sine x. The seventh derivative will be negative cosine x. All right, so I'm to this step right here. The fifth derivative at 0 will be 1, so this is going to be plus x to the fifth over 5 factorial. The sixth one, since it's a sine, the sine of 0 is nothing. And then the seventh one is a negative, so it's going to be negative cosine 0, so it's going to be negative 1 x to the 7 over 7 factorial. So those are my first 4 terms for sine x. All right, that was worth 1 point. Right? Notice all the work that I had to do for 1 point. So notice how much easier it would have been had I just had sine of x memorized, but that's another story. All right, it also asks us to find the Taylor series for sine of x squared. So all we need to do is go into the sine of x function, and we're just going to plug in x squared wherever we see an x. So sine of x squared will equal x squared minus x squared cubed plus x squared to the fifth over 5 factorial minus x squared to the 7th over 7 factorial. And then all we need to do is just clean it up a little bit. We'll get x to the 2nd minus x to the 6th, because we're multiplying exponents, plus x to the 10 over 5 factorial minus x to the 14 over 7 factorial. That part was worth 2 points. So if you made any little mistakes in between, then you could score yourself accordingly. All right, part C, find the value of the sixth derivative of, oops, I think I missed a part. Let me go back. I did part A, I did not do part B. Okay, write the first 4 non-zero terms of the Taylor series for cosine x about x equals 0. Okay, on this one, I'm not going to do it the long way. I'm going to assume that I have the formula memorized, because we found in part A it would have been so much easier. So cosine x, and we need the first 4 non-zero terms again. So I'm going to have 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Okay, so I did that. That was worth, oh, that was worth nothing. So, okay, because, wait, the series for cosine x, that was actually worth a point. Good. Okay, the next one we're going to, it said to use this series and the series for sine of x squared, so we're going to use this one right here, to write the first four non-zero terms of the Taylor series for f. So we're going to have f equals, all right, so basically what we need to do, because f is equal to the sine of x squared plus cosine x, we basically just need to add those two different ones together. So we're going to have cosine x plus sine x squared. So we're going to put these two together. So I'm going to have 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x squared minus x to the 6th plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial. Okay, so now we just need the first four terms. So the first term for sure is going to be 1. The next one is the ones with an x squared, and I notice 2 factorial is, for these two, they're both x squareds. So let's have 2 factorial be the common denominator, and 2 factorial is just, I need to multiply this one by 2 factorial, which is just 2. So if I have minus 1 x squared over 2 plus 2x squared over 2, that's going to give me 1x squared over 2. Okay, so those are gone. The next one that I notice is an x to the 4th, so there are no like terms with that one, so we just get to carry that along. And then the next one is I do have an x to the 6th. I'm going to make a common denominator of 6 factorial. So I would need to multiply the top one of this one by 6 factorial. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 120. So I have minus 1 x to the 6th minus 120 x to the 6th, which is going to be minus 121 x to the 6th over 6 factorial. So I do have my first four terms, so I will stop. I don't need to include those other ones. So that is the first four non-zero terms of the Taylor series for f. So that was worth 2 points. And it just says those are the points. It doesn't tell me how to break them down. All right, part C, find the value of f of 6, 0. So we knew that f was equal to 1 plus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and it wants us to find the value of the derivative, the 6th derivative at 0. Okay, if you can remember where this formula would have come from, remember it's always, I'm going to write it below, f of 0 plus, so it's the first derivative of 0, x, plus f double prime of 0, x squared over 2 factorial, plus da-da-da. So if I want to get to the 6th derivative, I know that it's going to be the 6th derivative at 0, x to the 6th over 6 factorial. So if I'm comparing the terms in the sequence, I notice that this, whoop, that was 121. This problem goes with this problem. So notice if I'm comparing these two parts, they both have the x to the 6th, they both have the 6 factorial. So that must mean that f, the 6th derivative of f, is going to match this number right here, which is negative 121. So my answer, the 6th derivative at 0, is equal to negative 121. That is worth 1 point. All right, part D. Let P of 4 be the 4th degree Taylor polynomial for f about x equals 0. Using information from the graph of the absolute value of the 5th derivative, we are going to show that the difference between the polynomial and the actual function is off by less than 1/3000. So basically, this is asking us to find an error. Since this is not an alternating series, to do that, to find the error, we are going to use the Lagrange error formula. And if you remember, the Lagrange error formula looked like this. It was the max, and I'm going from 0 to 1/4, so it's going to be because it's centered about 0, of the, if it's the 4th degree, we want to find the 5th degree, and that is over 5 factorial, and then it's going to be times x minus a, my center is 0, to the 5th, and so that's how we're going to find it. All right, so we're going to find the 5th derivative, and we want to find between 0 and 1/4. So between 0 and 1/4, we want to find the maximum value of the derivative. So I think this is 0 to 1/4 right here. So what's the maximum, or did I go far enough? 1, 2, 3, 4, yes I did. So between 0 and 1/4 it looks like the maximum, maximum fifth derivative is about 40. I might be a little bit off, but I'm pretty close to it. So that's going to be 40. And then times, or actually it's over 5 factorial, and then times, my x value is 1/4 because that's where we're doing our general error at. 1/4 minus 0 will be 1/4 to the 5th power. Okay, so basically, hopefully you saw, we remember this was the maximum my derivative is going to get to. So that's the maximum the derivative got to is about 40. So then from here, we're just going to plug that into we're not going to plug that into our calculator because it's a non-calculator problem. Great. So we are going to try to do this without our calculator. So we're going to have 40 over, let's see here, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. And then times 4 to the 5th, because the 4 is on the bottom. Okay, so this is just interesting. So let's see here. I think what I'm going to do on this one, let's just make my life easier. 40 and 120 will reduce to 1/3. So hopefully that made it a little bit better. Okay, 4 to the 5th, since we don't get to use our calculator, 4 times 4 is 16, times 4 is 64, times 4 is 256, and I need to do times 4 one more time. Let's see, 22, 8, 1024. So this is going to be 1 over 3 times 1024. Now I get to multiply by 3. So if I do that, I get 1,372. So hopefully we were supposed to show that I get an answer that's less than 1/3000th. And I did get an answer that's less than 3,000. All right. If you just even wrote down the correct formula that we're going to use and you tried to plug things in correctly, you're going to get a point. And then if you're able to actually get through to an answer, you're going to get a point as well. So another formula you get to memorize.